Hello, everyone, and welcome. Thank you all for joining us today. My name is Firas, and I'm the event planner for Microsoft Reactor in Redmond. Before we start, there are some things I would like to go on with. So first of all, please take a moment to read our code of conduct. We seek to provide a respectful environment for both our audience and presenters. We encourage engagement in the chat, but please be mindful of your commentary and please remain professional and on topic. The session is recorded. It will be available through Microsoft Reactor YouTube channel in about 24 to 48 hours. I'll be sharing the link of our YouTube channel in the chat. I'll also be sharing some links to the Reactor Mira page and also a link to our survey. If you have a chance, we'd love to hear back from you. Which brings us to our session today. This session will run approximately for 2 hours. Our speakers for today are Jim Bennett, he's a senior cloud advocate, and Sam Ronsky, he's a regional cloud advocate. I'm now going to hand this over to both of our presenters.
Cool.
Awesome.
Thank you very much. Thank you very much. So hey everyone, welcome, good morning, good evening, good night, wherever you are in the world. So I'm Jim. I'm a regional cloud advocate based up in Redmond. If you haven't come across me before, I like to play with IoT devices and Lego, hence all the glorious Lego behind me. Sam, do you want to say hello?
Hi, I'm Sam. I am the regional cloud advocate here for San Francisco, and I like making things and tea, which is very relevant for what we're doing today.
Today is all about tea, isn't it? Today is all about tea.
That's the plan.
I guess the important question now is, what tea are you drinking? You know, let's go on with tea. What tea are you drinking right now?
Haven't decided yet. So because we're doing this, I grabbed a whole bunch just to kind of showcase a few different types. Because tea goes in all sorts of different styles of things. You have like white teas. I don't know. I'm holding up the bag. That's maybe not as useful. But then they vary in different oxidation levels, and that causes them to taste very, very different. If you've had a green tea, you might notice that it tastes very different. Has different caffeine content and different things than maybe a black tea that you might be more used to. For me, I typically go with lots of oolong teas, which are very flowery and very nice. But what we're doing is kind of exploring them. There's a whole bunch of different things. Hopefully we get to kind of share some of at least my passion for tea. And I think Jim's. I haven't exactly asked this specific question, but I think you enjoy tea too.
I do, yes. So I'm going to go a little bit against my heritage. Yeah, as you can probably tell from the accent, I am a Brit, and I am obviously traditionally supposed to be drinking a good strong cuppa. You know, some PG tips or some Yorkshire tea with milk and sugar or what have you. I don't really drink tea that way. I've kind of got out of the habit of drinking traditional British tea. I lived in Hong Kong for a while, so China's very, very big on tea, and I got into a lot of green teas, jasmine teas, flower teas. So I do enjoy green teas. I usually have that most days in the afternoon. I'll have a green tea. I also like, I'm going to hold this up for the camera, also like flower teas. In fact,
Those are so cool.
Let me just, since as my screen is currently shared, let me just zip over to my camera. I don't know if you can see flower in there. It's pretty cool. Starts off as like a ball, a tight ball, and then as it heats up with the water, kind of opens up, and then the flower comes up. And then you get different variants where the flower, if you've got in a tall glass, the flower will float all the way to the top. It's very nice. It's very pretty.
Those are some of my favorite. I'm a big fan of like the floral teas. So I mentioned oolong teas a lot, and I like doing that. I've recently been experimenting with adding like orange blossom water to it, mostly as a way to just add spice. I think a lot of people get introduced to it with like mixes and blends, because I think that at least that's what I see a lot is lots of like blends of teas. I have this one that I got from Canada. And this is like an apple black tea blend. So there's apple and I think a little bit of sugar. and then just some black tea, and then you get something a little sweeter or a little bit more familiar tasting than you might get with something else. Yeah, there's lots of different options. There's even tisanes, which is just herbal teas or things that don't have tea in them, but go in water. So I think technically like coffee is a tisane, but I could be wrong.
It goes in hot water, but isn't tea. Is a tisane, so that can mean if I have a bath, I'm a tisane. Yeah.
You know, I honestly don't know. I was looking this up before because it's not a word that I even knew how to say. I just read it and was trying to figure out to make sure I was saying it correctly. So that's my knowledge. But yeah, you basically just experiment, have fun. That's sort of what we're trying to do today, is just kind of have fun and show some cool tech stuff alongside all of this, right? So
yeah,
and that's why we're here.
So yeah, just to set some background for why we're doing this, I think it's probably a good thing that we set a little bit of background for our viewers as to why we're actually doing this. So as you can probably gather, Sam likes his tea. Sam likes a lot of tea. And the curse of the modern world is when you go and you make some tea and you've run out. It happens all the time with all manner of things. I've finished up some coffee today, and luckily we have spares. But you don't want to run out, do you? So we are tech geeks. We are people who do interesting things with gadgets and devices. So kind of one thing we got to talking about was, what if you run out of tea? So that's kind of for the benefit of the viewers. So that's kind of our background on this. So Sam, do you often run out of tea?
All the time. It's really weird because I don't like run out where you just don't have anything, but there's always that one craving, right, where you're always like, I want this, and then you realize that you've wanted that a lot. So I guess we have a donation train, but anyway, there's a whole bunch of those different things where you want this specific thing and then it's not there. And then you want to figure it out. And I've done some work previously with supply chains and trying to figure out how do you solve these like out of stock issues, and how do you make it so that when you want something, it's actually there and it's easy to actually have access to these things and make sure things are in stock. So we were talking, and it seemed like there were some cool options to kind of take some of those like enterprisey style things and boil them down into something that you could put on your shelf and just get to run for like a really fun experiment, and also something that's actually hopefully genuinely useful. That's sort of what I'm hoping for. So,
an important question: was the boil them down? Was that a tea pun?
Maybe there might be a lot of unintentional ones, but I don't know.
So how are we gonna do this? How are we do this? We got scales, haven't we? We've got scales. That's kind of what we were thinking, wasn't it? Scales. So should we do some architecture? Should we try and work out what we want to do with this?
Yeah. Let's talk about this. We should probably talk a little bit about this series, I think, and kind of introduce it just so people are a little bit understand like what we're doing and what the constraints we're under are, because we have 6 sessions. We have 2 hours each session for 6 different sessions. So that's 12 hours to build a tea monitoring system. And so hopefully by the end of that 12 hours, we've explored this. We have done a little bit of work behind the scenes to kind of make sure things are working and we actually understand what we're talking about. But we've also left a lot of unknowns. When we're talking about architecture, it's because we don't know what that architecture is going to look like yet. Mm-hmm. And so part of like the fun here is we can kind of drive this conversation and hopefully discover solutions and hopefully take some input from you, the awesome viewers, to build some cool things. So that's sort of what we're hoping to do, is kind of explore this and make it a little bit more fun. So yeah.
And this is very much a relaxed session, isn't it, Sam? So if you got any questions out there, if you want to put any comments, you want to point us in different directions, want us to dive into something, just stick a comment in the chat and we'll pick it up and we can answer your questions. We can dive into different directions and we'll just have a bit of fun as we work out how to completely over-engineer making sure that Sam has got tea.
Yeah, that is a good point. This is probably a little bit over-engineered to start slapping all of this stuff together to track a bag of tea and make sure it's not running out, when you probably could just buy like 10 bags of tea and then just replace them when they run out. But that's less fun and is prone to flaws. What if you forget to do it and then you keep forgetting? So this will remind you. Yeah.
This is more exciting than Amazon's subscribe and save, where they automatically send you stuff every few months. This is more exciting.
Well, and your uses may change. Like so the interesting thing with tea, and this happens with a lot of things, I think, is when you're, for example, like black teas. I really like those in winter. I live in California, so there isn't really a winter anymore. So I don't really drink them. But when I was living in the Midwest, during the winter, black teas were fantastic, especially like a good Earl Grey or something. And so that was like a winter thing. So usage was very different during the winter than it was during like spring or summer, when you want something that's less strong or less hot, because black tea you brew much hotter. So it's like those things change, and so I think we might be able to even start exposing some trends as this goes on, of like how preferences are changing and how things are going different. So
I have multiple monitors for it, so you could tell that yes, in the winter I'm drinking more of this, summer I'm drinking more of this one. Then machine learning the whole thing and get predictive algorithms to buy your tea.
Right. Obviously, with one person as a sample, that might be really, really hard. We might have to make some pretty broad sweeps, I think, with our guesses there. But things like that are things that you can kind of start learning as you start grabbing this data and start analyzing it. That's sort of like one of the things you can build into if you're looking at this at a larger scale is how you can actually expand on this and use this to actually analyze trends and be like, hey, a bunch of people buy black tea in the winter and it's fall right now. Maybe we should order a bunch of black tea before it's all sold out. Things like that can be really helpful telemetry and kind of give you that I don't know, nice decision making choice. So
random story. I love the smell of Earl Grey. Sonia mentioned Earl Grey. I love the smell of Earl Grey because my grandmother used to drink it. And so, because it's flavored with bergamot, and that's very pervasive smell. And so my grandmother used to drink it all the time. She'd be like, yeah, pot of tea after pot of tea after pot of tea. And her house always smelled of Earl Grey. And you know how it smells? They're kind of, they really are very good at triggering memories. So the smell of Earl Grey is my grandmother. And yeah, she passed away a fair few years ago. 10 years ago, maybe more than that, in fact, 12, 13 years ago. But still, whenever I smell that, I think of her. So, random Earl Grey story there for you.
Oh, nice. I think that like that's the cool thing with these kind of things is hopefully this is something that actually can be like shared with people. I think I don't know, like the thing with tech is you can kind of take it in your own direction and do whatever you want. But hopefully this is fun and inspires you. I have some Earl Grey on my desk actually. It's not traditional stuff. I think this is from Taiwan, and it is a oolong Earl Grey. So it's not made with black tea like you'd probably find, and it also has some vanilla inside of it. So
different.
Yeah, cool. We were going to talk about architecture. Should we jump into that a little bit?
Yeah, well, I guess should we start with actually how we're gonna, before we jump into the architecture, should we start a little bit with what we're going to measure? Because if we're going to architect a whole system, really, what is the input into this architecture? And really, I think to set the scene a bit, it's weight, isn't it? That's kind of what we're taking as our input. We're working out whether or not we need to buy tea based on the weight.
Right, and we did cut a few things out when we're talking about this. We're initially discussing things like machine vision and things like that to be able to detect things on your shelf, for example, and be able to select like things in your pantry and be able to identify those kind of things. And then we realized that most things probably shouldn't have light exposed to them and things like that. And so we moved into something a little bit more specific and also a little bit hopefully more fun. It means we get to drink tea. So, but this gives us a way to kind of measure weight, which seems like a nice way, and it's something that you can't do with machine vision, especially if you're one of the people who stores your tea or spices or whatever in a jar. And I should say we're talking about tea here, but you could totally use this for like flour or sugar or rice or any of these other like pantry staples that you have in your home. It should just work for all of that. I don't see any reason why it wouldn't. But yeah, that's why we chose weight, is because a lot of this stuff you're not going to actually be able to see the contents of it. You're going to do that. So yeah.
Because I mean, IT, it is used a lot in stock tracking. It's used a lot in retail. The whole vision-based IoT, that's the popular one. So you'll get like a supermarket shelf with a camera above it, and that camera will look at what's on the shelf and spot any gaps. Does like object detection and sees that yes, there should be 4 boxes of cereal there at the front. I'm only seeing 3, therefore we're missing it, and kind of can do that for stock checking. But yeah, vision relies on light, and I mean my pantry, when the door's shut, you can't see in it. So we can't really go down the vision route. The weight route kind of works. It's if you've got a thing on there, you can monitor the weight. If you've got a sealed jar, you can't see into it with computer vision, but you can weigh it. And so we can use that, because by tracking the weight, we can build up a trend, can't we? We can kind of get that idea of this is how fast I'm drinking my tea over time. So it's not just about knowing I've run out. It's also about making predictions on when you're going to run out. Because if you've got, you plot a graph of tea usage against time based off weight, you can kind of weigh, this is how much the weight of tea, and then it goes down over time. You can kind of draw that trend line and use that to make that prediction as to when you're going to run out.
Right. And I think I like, at least my example might be a good example of why like just vision might not help you too, is I buy a lot of this at the same time, because a lot of it comes from overseas, or I get shipped in because sometimes it can be hard. There are a few places in San Francisco that make it pretty easy to get really, really nice tea and things. But a lot of the time, like if you're getting that, it might sit on your shelf. That was a tongue twister. It might sit on your shelf for like a few months or something before you actually do anything. And then what does that data mean at that point? If you haven't actually used it for 2 months, but it's there and it's in your database, and then it disappears a month later, did it take you 3 months to eat it, or did it take you 1? So hopefully this kind of helps us answer that. I think. So
yeah, because you kind of see when the decline started. So if it was just flat for a long time, you can kind of ignore that as not being used, and then when it starts to go down, when you spot that start of the trend line.
Right.
So question for our audience, this would be good to know. Who drinks tea? And if you do, what type of tea do you drink? Do you want to stick your remarks in the chat on whichever of the various viewing places you are? And so we'll pick those up. So yeah, tell us what tea you're drinking. We're kind of interested to know.
Do you wanna tell me your favorite? So
my favorite is probably, as a kind of an everyday, is you get the little green tea pearls. So it's little tiny pearls. They are, teeny tiny. They're only kind of like yay big, all tightly bound up green tea, or jasmine flavored green tea. So those ones, and you just drop those a few of those in some boiling water. Let it kind of seep. They kind of open up a little bit. I usually put it in. I've got a metal kind of thing that sits in the bottom of a cup. Fill that up, and it just seeps into water, and it slowly over time it gets a little bit heavier, stronger as the flavor kind of builds up over time, and then you just keep topping it up with hot water. When I used to work in Hong Kong, yes, them things. Yeah, when I used to work in Hong Kong, this was many years ago. Tea was obviously everywhere, so I'd have a mug on my desk, and it was basically one of those clear glass, insulated mugs with kind of like a filter built into the top. So you'd have the tea in the bottom, and then as you drink it, kind of the filter stopped you drinking the tea. But then what the company I worked for had is they had, I guess the closest thing would be the traditional British tea lady to, and that's very much a stereotype. These officers used to have somebody who would bring tea around every day back in the UK, 50, 60, 70, 100 years ago. Kind of had someone like that. And she would bring tea, but she would basically bring a big thing of boiling water and just go around just topping up everybody's tea. And so we all had our mugs of tea, and she would come along and just top them up. And one set of pearls would last you the entire day.
That is actually probably something that I should call out. If you are making it out of like loose leaf tea, like those dragon pearls, or any other loose leaf tea you buy, you don't need to just get rid of it after one use. The flavor actually evolves over time, and so a lot of those different loose leaf things, you can steep them 5, 6, 7, 8 times depending on the type of tea, and it will actually change in flavor over time and still be good. So you don't just have to like make it once and then be like, okay, it's done. It doesn't work quite like that. I will share mine, but first there's a whole bunch of comments that we should go through that people have shared.
James Walsh Jr. has said the 11 a.m. and 2 p.m. tea cart. I missed that. But yeah. Some place I've worked at, that is a thing. My dad, actually, he used to work at a place where on Fridays, the person who did the tea cart would fry up bacon and bring around bacon sandwiches for everybody. And it's like, can't get any more civilized than that. Someone bringing a bacon sandwich to you. If you're into bacon, of course. But, just someone bringing you a hot sandwich on a Friday morning with some tea.
I'm really curious. Somebody commented they like dandelion tea. And I'm curious, is that dandelion root or the flower or something else? Because I've used that in
the flower. Well, so Charitable Choice says it's a flower. But yeah, for the tea, do you make the tea with the flower or the leaves?
Interesting. Yeah, somebody's saying flower and petals, because I've used it when making dandelion root. Okay.
Yeah,
roasted dandelion root. That sounds really good. I use that in root beer when I'm making root beer at home.
There's another traditional British soft drink called Dandelion and Burdock, and that's like kind of like a soft drink, like a cola, but that's flavored with dandelion root and burdock root. So dandelion tea could be interesting. So what else? Eric Helling says anything black tea suggestions. I mean, this is where we're going to probably open up a whole world. So Sam will now talk for remaining 1 hour 37 minutes about all the suggestions for black tea.
Honestly, I think the best thing to do is to find a local tea store near you and go there. Lots of tea stores have tea on tap. If you're in the San Francisco Bay Area, I recommend Red Blossom. They have tea tastings and it's super good. They'll walk you through where the teas are from, how to prepare them and what's good. But very, very, very nice place to do that. Otherwise, most other places have a local tea store. If you can find one, I highly recommend just going to them and talking to them. The people working there are going to have really good suggestions about what they have in stock. And that'll be a good way to kind of like get local suggestions, because a lot of that stuff gets prepared locally. So I think that's my suggestion. Otherwise, you can just go and find some things. Red Blossom does delivery, so if you're, I think in the US, I don't know outside of that, unfortunately. But there's plenty of other places that will deliver different things. So if you're looking for suggestions, that would be my go-to. And also, you can buy tea in like up to like the kilogram sized things that look huge, like this. Don't unless when you're looking for something, don't do that. Buy it in these small little packs like this, and that way you can try a bunch of different things and see what you like, because that will actually last, even if you're drinking every day, that's going to last you a week or two. And so you can at least figure out if it's good, figure out if you like it with honey or with something else, and then figure out whether you want to actually order more of it, and that way you get to try more. So that's my suggestion. Lots of people were saying Irish breakfast tea, which I have actually never had. Which
No, I've had English breakfast, and also Yorkshire tea, but not Irish breakfast.
I don't see. See, the interesting thing is most of the teas that I've had, I think, are from Japan and China. I've had very few like British teas, like gunpowder green and like those traditional teas that I think are pretty common in like tea bags and things. I've never never really tried those. I really should. Anyway.
So, I mean, tea bags are okay, but you want to make it in a proper pot. You know, you got to make it properly in a proper teapot.
Honestly, however you enjoy it, I think is good. The only thing I will say is there's lots of different ways to, if we're talking about this, there's lots of different ways to prepare tea. And so you can do whatever works best. Like you can have a strainer, like something like this that has just a strainer in the bottom. Or you can do this, which is a gaiwan. Something like that. They'll work different ways. The tea strainers can get a little bit annoying if you have like if you are doing like the finely ground tea. I find things get stuck in them and they're a pain to clean, and then it just discourages you from actually doing that. You can find compostable like tea bags that you can fill yourself. Those are a good option if you're interested in that. And they're easy because then you can just like fill them and then take them to work or something. And it's good to go.
My wife does that. She drinks rooibos, which is South African red bush tea, and so she's got that compostable bags, and she like puts a scoop in there. She likes it quite strong. She fills it up usually to a couple of scoops, tie it up tight, use that to make tea, and then it's compostable. So you just chuck it in the compost.
I used to love that with vanilla. I would have it with like vanilla bean paste. And like make a big jug of that and cool it in the refrigerator. But yeah, I do have some pu'er. I think that's how you pronounce it, but it's right here. That if you're not super sold on tea, but you are curious and you like coffee, that can be an interesting place to start. It's very earthy and dark. So yeah, lots of fun things. I don't know. Have fun. That's the point.
Yeah, as some James Walsh Jr. says, let the holy war on teas begin. But no, I don't think there's a holy war. I think if there are people who've got disagreements on tea, we should all sit down, have a cup of tea, maybe a slice of cake, and talk it through. No need to have a holy war about it. Best to have a cuppa and a slice of cake.
Perfect.
Gizmo Joe used to drink a decent amount of rooibos with peach.
Ooh, that sounds good. All right. I'm getting hungry.
I find rooibos quite sweet. So when I used to drink tea, like a nice cup of PG Tips, I wouldn't have any sugar in it. And I find rooibos a bit too sweet, I must admit. But my wife loves it, so I must just suggest with her with peach. Oh, and James Walsh Jr. be right back getting a cuppa. Nice.
Perfect.
Though one of the best tasting teas is when you have just a mug of good old-fashioned Tetley in a chipped enamel mug with a chip butty. In some kind of greasy spoon cafe. Chipped. It's got to be a chipped enamel mug. There's something about the chips in the enamel mug. Kind of mug where you can see the tannin stains on the bottom from years of use. One of those with a chip butty is just heaven. Sam, you're looking horrified at that prospect.
I recently broke a thing. It's a whole thing. It fell off the desk and yeah. So there's a shattered cup. Anyway. Should we talk about the architecture of what we're actually going to build? Because we've sat here for 30 minutes now talking about tea, and it is great. But now I'm hungry. And I think we're supposed to be doing tech here.
We are supposed to be doing tech. Hey, everyone's enjoying the tea chat, so
exactly. No, this is perfect. This is exactly why we wanted to do this because this is way more fun. So yeah. So we've already established we've got scales, haven't we? We've established we're going to have scales. Let me bring up a drawing tool. Unless you've got a pencil to hand. Let's get a new document. I don't have...
Nope. There we go. So we've got some scales, haven't we? Let me draw some boxes. Let's draw some boxes. Here's a box. Put some text in there. My text does not need to be that big. Let's make my text black. Oh, come on. Back and make my text substantially smaller. We have some scales. Now we need to. If this scale is going to weigh things, aren't they? So we're going to have a jar of tea sitting on the scales. So I even draw. There you go. I'll even draw that. There you go. Jar of tea. Yeah. This is one of the finest architecture diagrams. I believe this is full UML or whatever thing people are using, isn't it? Isn't that right?
Yeah, I think that's technically what it's called. But this looks great. No, this is perfect.
Now, obviously, the scales. You know, we're going to do some kind of hardware for the scales. We'll be showing off the hardware in a minute. We have actually tested the hardware, so at least mine works. So we're gonna do scales. Now this is my area of expertise here. This is the IoT world, which is kind of where I like to live. So these scales, we're going to need to connect to some kind of IoT device. That's what I like to do. Now, my particular favorite is a Raspberry Pi. So we're going to do a Raspberry Pi for this, because who doesn't love Raspberry Pis? I only have, 1, 2, 3, 4, 5, 6, about 8 of them behind me if they're not plugged in. I've got pies of all size, from that one to that one, all manner of pies. So we're doing pies. I love pies, and if I carry on saying the word pie, I can imagine Sam's gonna get even more hungry.
Yes, a little bit. Our chat linter has said that there's no UML issues detected, so I think we're perfect.
Excellent. Thank you.
We're going to pass code review. So we're good to go.
I mean, if you want, I can even draw a line. There you go. Draw a line between them.
Perfect. Lines make everything better.
Yeah, I think they're supposed to be like a triangle one side or the other, aren't they? Or a diamond shape or something. I don't know.
They do actually mean something, right?
Yes, they do. Yeah. One is like composed by, one is... Because you've got inheritance and composition and fields you can define by using the different arrows, and then you fill it in or not have it filled in for the diamond on the end, depending on whether it's actual a part of it or whether it just holds a reference to it.
Right. I think this is why I'm not an architect.
I actually did a Rational Rows course. So there was a company called Rational, that got bought by IBM, I think, and they had a tool called Rational Rows, and that was their drawing tool. And I did a whole UML with Rational Rows course back in 1998 when I was interning, and I then had to use it again in the world of work at about 2000, 2001. And there used to be a thing where you could draw UML diagrams and click a button and create C++ code. And then you make any small change to C++ code, and then it would just break everything, because you couldn't go back, because although it had comments to help it go back, it failed a lot of the time when you made any changes to the code. So it was great for generating code, and then after that, completely useless. And so we all gave up on it and just wrote code.
I've made that exact mistake with databases, where you visually design a database and then you compile it into code, and then you change the code, and then nothing works anymore. Done exactly that, I think. Not quite with UML. I have avoided it.
Yeah, Rational Rows is too many .petal files. Yes. God, yeah. Rational Rows files, massive, great big files. Yeah. But anyway, so this is proper UML, as Eric is validating for us. This is proper UML. So we're gonna have an IoT device, and obviously, IoT device, it's IoT is the Internet of Things. So we have the internet and we have a thing. So we're gonna have this thing connected to our scale, and then we need to connect it to an internet. So we kind of have two choices. Obviously, we're gonna be using Microsoft IoT services, because we both work for Microsoft, so we might as well use Microsoft services. We get free access, so But no, so Sam, we've got two choices of IoT services we could use. We have one called IoT Hub, and one called IoT Central. Now I can't spell Central with one R. So IoT Hub is it's an IoT service. So it's like it's not an application. It doesn't have anything fancy. It's behind the scenes service. So if you've done stuff like events and message brokers and stuff like that, it's a message broker, but it's got all the special magic for IoT devices for security and device management and firmware updates and blah 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 blah. But it's just a pipe. So or just a broker really. So you can send stuff to it from your IoT device, and then you can pull stuff off the other end. And then you have to do all the things. So if we want to store the data, we want to plot the data, we have to do that ourselves. Now, the downside is obviously you have to do that yourself. The upside is you've got so much control. Because I know when we kind of chatted about this before, we've had all these great visions of dashboarding and that kind of stuff with some great tools. So to me, it makes sense to stick with something where it just does the basics so we can build on everything else. Because the other option we have is IoT Central, which is our software as a service platform. So it's basically a web application. You spin it up, you send your data in, and you can drag and drop charts and graphs. And then if you want to do other stuff, you kind of have to put an export to a message broker on there and pull stuff off the message broker. So it's kind of great for building applications, great for seeing things quickly. But I think with our plans of building up a whole massive, overly engineered IoT architecture, we probably don't want to have the charts and graphs now. We want to kind of build this later on as like sort of a second part. So I'm thinking IoT Hub was kind of our way to go.
I think I agree. My background is a lot of open source tools, and so especially like IoT Hub, I'm still learning, and definitely not an expert in that. I'm gonna rely a little bit on you there, but I personally think that separating things into their different components is helpful in the design, and having something specifically to just route our messages where they need to go seems really useful. So let's explore that.
Yeah, I mean, IoT Central is hugely powerful. So Keurig, the coffee maker people, they're using it to manage their new smart coffee makers. So it's incredibly powerful with what you can do with it. But obviously that's coffee, we're tea. So, do we have to kind of not use IoT Central because it's the coffee one? But no, IoT Central it's ridiculously powerful, does a lot of great things. But I think it'd be more fun. I think we better show off a lot more stuff and just try and play a bit better if we kind of go the less fully featured route. So we have to build up a lot more of those features ourselves. I think that's a bit more fun. And obviously IoT Hub, because I say it's a message broker, so messages come in, they've got to go off somewhere. I've put an interface on here, which I don't know if Eric can double check whether this is, I believe this is the UML for an interface. So we can now take something off here to put it places.
I wouldn't know. So looks good to me. So
yeah, I'm sure this is terrible. There's probably architects who are watching this who are just like weeping. Like, what are these people talking about? I think one of the most important things about architecture diagrams is everybody who looks at them has to understand them. So it kind of doesn't matter how you draw them as long as everybody knows what they mean.
I think that's, the key thing is you should be able to come back to, it's the same thing with code, right? You should be able to come back to it a week later and not be like, what is this? Because it can be really easy to like solve a problem and be like, oh yeah, that's good, and walk away and have no comments and no anything. Same thing here. I understand what's going on. We've got a line. Like I think right, like that's that. And maybe we could turn this into some cool graphic or something and actually have like real thing. Anyway, but yeah, I think it works.
Yeah, I think it kind of works. So I guess a question for the audience then, moving away from T questions, is let's move from T to IoT. Has anyone done any IoT? Has anyone actually played with any IoT devices, use things like IoT Hub? If you have, put in the chat, share what you're working on. If you've got any links to any cool projects you want to share, please share it, because I love IoT gadgets. So I love when people show off what they've made. So, yeah, share your IoT glory stories in the chat. So this is kind of the IoT part. IoT, exactly. Yes. If you can't pun on IoT with T, what can you do? MX Dev Kit pushing up to IoT hubs, as James Walsh Jr. Awesome. So the MX chip, the Dev Kit. Oh, which box is that in? I've got so many kits and so many different boxes. I think it's in this box here. You'll not believe how much rubbish I've got. Not that box. Is it under here somewhere? That's me thinking I just whip one out to show off. And they're all probably buried under something. Is that? Oh, is that one? Please. No, that's not one. Here we go. Yes, I found one. Yay! I recently reorganized my office, and I've got so much stuff just dumped into crates, and it's just impossible to find anything. There we go. Let's move that away before I smack into that and hurt myself. So, the MX chip. I will take a moment to talk about this. I love this device. This is it. In fact, you know what? Let me take advantage of big camera. This is the MX chip here. It's a fantastic device. It's not a Microsoft device as such, but we partnered with a company to manufacture it. It's got Wi-Fi, Bluetooth, used for things like that, microphone, headphone socket. It's got a whole lot of different sensors. You've got temperature, pressure, humidity, gyroscope. You've got LEDs. You've got buttons. You've got an OLED screen. And the connector on the bottom here is the same as the BBC microbit. So if you ever used a BBC microbit, you can use this with the same hardware. So if you've got like one of the little caddy things, you can put the microbit in to control robots. You can plug one of these in there. So you can use one of these to drive around a robot. And so it's Arduino compatible or uses Azure RTOS, which is a Microsoft real-time operating system. It's even got a special little Azure light that lights up blue when you're connected to IoT Hub. And it's a great device. We do have a simulator for that, actually. So if you want to try one out, we do have, let me see if I can find the simulator. But it's a kind of a great little device. If you want to do some Arduino programming, let me just drop a link in the chat. I have to drop it into the private chat, and then that'll be dropped into the main chat. The magic of using StreamYard to manage chats, I have to send it to one of our experts here to pass it on. But it's a great little device, actually. It's a nice little bit of hardware. It's about $35. So it's expensive for an Arduino chip, but it's for what you get in terms of sensors built in, it's kind of good value for money. And it's a really, really good board. I've done a number of workshops with these boards. Absolutely fantastic. Love these boards to bits. So James, yeah, thank you for giving that a shout out. It's one of my favorite IoT devices. Kevin says, I'm working with vehicle components, going to Solace, AWS IoT Core. Oh, cool. Yeah, vehicle monitoring. That's a big thing for IoT, or just any kind of transport monitoring is massive, because the amount of data you're capturing from different devices, different machines, it can be used for so many different purposes. So just things like predictive maintenance. Like your average Rolls-Royce engine is packed full of thousands upon thousands of sensors monitoring everything and running it through AI models, so that if it goes wrong, then you're notified, you can do predictive maintenance on it. Cars have got sensors on them, whether it's just like a tire pressure monitor or even actually sensors to work out where you have GPS sensors, that kind of tracking. That happens a lot. I used to work for a company in New Zealand, actually, that did telematics. So it'd be boxes that would go in a truck to work out where the truck was. So you could do mileage measurements on road and off road, and you could tell how fast you were driving, whether you were speeding, whether you're going too fast around corners, a whole lot of things like that. So yeah, vehicle stuff is great. It's a massive area. We're all into monitoring every kind of machine at the moment in the IoT spaces. Let's monitor all the things. And so vehicles is huge. And kind of really all the stuff we're talking about now, yes, we're measuring weight of tea, but you could do that for exactly the same thing for the load on a truck. So if you wanted to monitor whether you're using, whether a truck's under load or not, how much, if it's carrying fuel, how much is being dropped off at various locations, exactly the same thing we're going to be talking about.
That was actually my first job. When I got into software engineering, my first like professional job was working on vehicle tracking using some of the OBD ports, which is what most cars have to kind of control the onboard diagnostics for everything, and being able to track exactly that. Like, do these things need maintenance, and are the brakes wearing out? Is the engine idling a lot? Is starting having issues? Are things going too fast or too slow, or not in the right place? Things like that. So it's very fun place.
So Kevin's point. So Kevin says, tricky part is that it can go offline at any time, car turned off, tunnel, etc. So things like tunnels, you have to combine it with map data to work out, it's disappeared. Is it a tunnel? It was heading towards a tunnel and now it's disappeared. And I guess for car turned off, that's where you get the OBD2 ports, don't you? You get those signals from the vehicle to say vehicle on, vehicle off. Those are actually important in the US. So more random facts here. The US recently released a few years ago, released some laws around tracking. And so you have to track who is driving a vehicle and how long they're driving for driver hours compliance. You're only allowed to do so many hours a day. And there's loads of rules about if it's snowing, you can drive for a bit longer because you're driving slower and all that kind of stuff. But all that has to be geared to the engine. So you have to start tracking from when the engine goes on to when the engine goes off. So you can't just have a box in the vehicle. It has to be hardwired into the vehicle to know where it's on or off. And some are doing it hardwire, some are doing it Bluetooth. You have a Bluetooth dongle in the OBD2 port, connects to like a mobile phone app for tracking on and off. But obviously we know how reliable Bluetooth can be. If anyone's ever had to use a Bluetooth speaker at any point, we know how reliable that can be. So, X 14's also been doing stuff with vehicles. Work with sensors measuring load of mining trucks and displaying it in tablets. Yeah, same as what we're doing with T. Same thing with mining trucks. Obviously a load is not the same each time. It's whatever gets scooped into the back. So you measure the load, can prepare for that. Yeah, it's very, very cool.
Nice. Eric said he's using Raspberry Pis to track some mobile storage units for local weather. That's pretty neat.
Yeah. That's pretty cool. Because the weather station is kind of a standard demo app a lot of people build for Raspberry Pi. You measure temperature, pressure, humidity. So it's great to actually think about a real use case for that outside of just checking the weather at your home. So yeah, you've got a mobile storage unit. You probably want to make sure that it's watertight if it's going to be raining, things like that. So that sounds really cool.
Yeah.
Nice. So thank you for sharing, everyone. As you can probably tell, I get very excited when people talk about their IoT projects. I love it. I'm addicted to this stuff. Anyway, we were drawing pictures. So we've talked about architecture-wise, take a reading from the scale, from our IoT device, and we can send that to IoT Hub. So it's just a message broker. We just send a message, a JSON document, whatever, send that over to IoT Hub. Now, IoT Hub is just a broker, so we can get stuff off. So we can take stuff off here and we can put it into a database, or we can put it into another system of whatever type we want. Now, the out the box without too much effort solutions you can have on here is you can put things like Azure Functions, so basically serverless code. So you can say whenever a message goes onto my IoT Hub, bit of serverless code to respond to that. So I want something that will put, here's my function, I write it in whatever language I want and run this every time a message comes through to my hub. And then from there, you can do what you like with it. You can bind it to databases or what have you. There's a thing called Stream Analytics. You can plug that in, and that you can essentially run queries over the live data. So those queries can be over individual values, over sliding windows. So you could say, do something when the value over an average of an hour changes by this amount. Take this and then send an output from that. And that output can then go to another message broker or a database or a function or blah, 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 blah. So you can kind of wire up different bits and kind of build a pipeline of stuff going around. You can just take it from IoT Hub and put it straight in a database. So there's kind of events you can hook into and just puts it straight into storage. So it's kind of up to you where you go from here. So I guess this, Sam, is where I turn over to you and say, you've done supply chain. I'm sending you data from the scales. What do you want to do with it?
So I think the questions that there's so many questions with like what do we want to do with the data? I think for what we're tracking, we're specifically looking at changes in await over time.
Mm-hmm.
So my mind is immediately on time series stuff, and I'm kind of excluding like blob storage, mostly because NoSQL might be the thing that I know the least about. So yeah, and then SQL, the I don't know if we need to store that many things, but like the cool thing with time series is it makes it really easy to analyze things in over time. If you have a data set that is defined by the time that something is happening in, a time series, or I just lost the name of the thing. Yeah, a time series database will work for that. So like typically I've used something like Prometheus with Grafana and as some way to kind of monitor that as just like some open source tools to do that, as a way to read that. I think so I'm not entirely sure, but I think we might be able to pull out some of the Prometheus bits and replace that with IoT Hub. I think that might be where the switch happens.
So
and then we just need some place to store it.
I've not come across Prometheus before. Brave Cobra 2 recommends Prometheus. So what is Prometheus?
Oh, it's been a few years. So I might actually need to look this up, I think. I think that might be the safest thing for me to do, because otherwise I'll probably be wrong. But I've typically used it as okay, don't just search Prometheus, because that's not going to help.
Dude stole fire from the gods, gets his liver pecked out by an eagle every night or something.
Yeah. Less useful. That Prometheus is an open source project that can monitor things. It's really nice for handling metrics. And there's a pretty standardized, I think it's part of Open Telemetry, I want to say. We're right on the cusp of the things that I don't quite know, which makes it a little bit unfortunate. But Prometheus does a whole bunch of things. It allows you to kind of retrieve information from a server. So kind of on a poll-based system, you can say maybe your web server or our IoT service is saying, here's the weight on this device. And it's publishing that as just a HTTP request that you can just reach out to and say, what is this? And it will return you this big JSON blob that says, here you go. Collects metrics and stores it in a time series database. Yes. And so you can do that and then grab everything. So it's just going to constantly loop over that and grab your metrics and store them in that time series database. Time series databases can collate data. So the useful thing there is if you are running IoT devices like the one we're running, I think can take like hundreds of readings a second, or maybe not that, but like 60 readings a second for something that is monitoring tea usage that is going to change maybe 4 or 5 times a day if we're like crazy. So like we don't need that much data. And so a time series can kind of allow you to condense that and prevent you from storing terabytes of data when you really don't need to. It can also keep it and kind of time it out for a set amount of time. So for example, if you're storing data for whatever, typically that's just going to, if you store it, it sits there forever. That may not always be what you want. You may want something to expire after a year or something like that. Or maybe you, like if you're monitoring a web application, one of the things you might want is to just check like its latency and uptime and things. You may want to have more specific data about that over, say, the past 30 days than you might over the past 365. And so if you want a really finely grained telemetry over that, you might scope things down, and then remove that high precision data after that period is out of the window. Things like that. So Prometheus could be cool. There is a Grafana like Grafana is sort of what my go-to for visualizations. It gives you really nice dashboards, plugs right into Prometheus, so it works really well. And I think there's a Azure offering for Grafana. I'm not sure about Prometheus, but I have been reading. There are some things that get close to that, so that might be an option for us, is to kind of grab the Prometheus or some other time series thing. I think you mentioned that.
So there is a Prometheus on the Azure Marketplace, so you could actually install it. So it's got configurations that would work for it. And I did see SUSE Server 15 SP2 with Prometheus and Grafana. So you could deploy a virtual machine that's already pre-configured with Prometheus and Grafana. So you kind of get everything all in one.
Right. I think though, I guess this can be a little bit back and forth. I use Prometheus, for example, with my Minecraft server because I want to track like players who are online and things. But that's it's constantly polling and asking that. I think our architecture is a push, right? We're pushing from our IoT device to wherever, not the other way around.
So if only Azure had some kind of tool for doing insights over time series that's designed for IoT. Maybe they could call it, because I know Microsoft likes to have very descriptive product names. Maybe they could call it time series insights.
I don't know. That sounds a little too convenient.
So one thing I always love is kind of comparing product names. So Microsoft, our product names are very descriptive. It's time series insights because it does insights over time series, which is great because you know exactly what it does. But if you were to Google time series insights, you wouldn't necessarily find the Azure offering straight away because there's lots of people that describe time series insights. Whereas companies like Amazon, for example, they come up with the weirdest, wackiest names. Yeah, we're going to call this green grass, or I don't know what other names they come up with, which are great names because kind of when you search for elastic beanstalk or whatever, Jack and the Beanstalk or whatever it was called, you'll find the product, but you have no idea whether you need to connect your green grass to your hippopotamus to your whatever. So I always find it weird trying to think about these different names. Is it good to have a name that's boring and descriptive, or interesting, but you got no idea what it means?
I think that's one of the things that, like, the unspoken of skills that you have to get as an engineer as you start working on this, because it's not just like time series insights is the thing, but also like Go. If you're trying to search for Go, the language, like the programming language, you're not going to find it if you're a new programmer and you just start searching for Go or Java. C# used to also have some interesting quirks because the hashtag, the sharp part wouldn't work in searches, so you would get things for like C, which probably wasn't what you were looking for. Prometheus, we searched for Prometheus and got information about a god. It's a weird thing, but you have to kind of figure out how to word your searches really well. It's taken me a long time to figure out, like, oh, I should start doing this or start adding these specific like keywords into my search in addition.
Yeah, I think the way you can gauge someone's seniority in terms of tech skills is give them something to search for and see how quickly they find it. Because that's, I think, the more senior you are a developer, it's not it's part of it comes down to just how good you are at working out how to Google something.
I could see that. I guess you'd know better than I would. I am still learning a lot of that, unfortunately, or fortunately, I guess. Learning is good. So
But it's something about you being careful when you search for things. So another story, my wife is petrified of snakes, like proper phobia. Not just like scared of, like a proper phobia. So I dread when my daughter starts doing Python in school. So if my wife ever has to help her and Google something, if she types Python in, then yeah, it's gonna be interesting when I hear the screams. Oh,
hi, it is me. Yes, I do have a Twitch account.
yes, make her own Twitch account. Why is Defluxka telling you to make her? Oh, hello, Defluxka.
Hi.
Python is great. Yes, Python is great. But yeah, if you're ever scared of snakes, not a language you want to search for. What do you mean Stack Overflows down? Yes. The standard response for a senior developer who can't actually find anything. Stack Overflow's down. So unwinding all that mental stack. So there is time series insights, which is another one from Azure, which it's got the database, it can store it. So it stores everything and it's got all the visualization all built in. So we can kind of play with this. Maybe later we can maybe play with Prometheus as well. Be fun to try a few different options.
Yeah. So one of the things that and this actually works really well with the format that we're kind of working in, that I've found really useful when like designing and planning things is what I've heard called spikes, which is just like bodies of work that are time boxed to a specific amount of time. In our case, we have 2-hour sessions where we're specifically like, we're going to do this. But the useful thing with those is you don't have to deliver a product feature necessarily out of those. You have to deliver a action item, some new way you're going to implement things. Maybe it's, are we going to use time series insights, or are we going to use Prometheus? But we can actually use that as a way to like set that aside. Whereas if you don't time box it, one of the issues you can have is you just dive into it and just never stop. You just keep going and going and going and going, and then who knows what's happening.
Yeah.
So yeah.
So we've got our 12 hours in total. So see where we get with each of these things.
Yeah, I think this sounds good. I think we can try time series insights. Do you think we'll be able to just plug in IoT Hub into time series insights?
Yep.
See if that works.
Yeah.
And then if we have some extra time, maybe explore some of the Grafana Prometheus stuff, or maybe throw in some other time series database. If we don't need the other bits of Prometheus, we might be able to just use like Graphite or something to store that, and that might just work.
Yeah, because I mean, time series insights, it's pretty quick to set up if you know what you're doing. You know, won't necessarily say it's quick if you don't know what you're doing, but literally when you set it up, you create it, and then you just add an event source to time series insights from your IoT Hub. Because it's all Microsoft products all in the same place. When you add your event source, see from the picture here, bring in an IoT Hub. That's it.
Oh,
done.
That's handy.
Data comes in because it's designed to take IoT data, and so because it's designed to take IoT data, it's been built to connect. So,
well, that makes it. Yeah,
we'll try
that's
it out.
Cool.
We'll try it out because obviously something that's very much specifically designed for IoT data is going to be limited as to what you can get compared to if we feed into a generic time series database and show it on Grafana. So, kind of, we'll probably get this will be quicker to set up. Probably gives us less capabilities down the line as opposed to Prometheus and Grafana. So it'd be good to kind of try both and just see where we end up.
Yeah, I'm curious what it'll offer, because like for at least for me, I don't go super deep into Grafana. That's never been my thing. I feel like if you're investing a lot into your dashboards, I think you're missing the parts of the automation that you can do to like detect, hey, this isn't quite working, and maybe you should do something. And so I've tried to I try to cut off lots of work into too many dashboards, but we have an entire episode dedicated to dashboards. So there might be a really good opportunity for us to dive into dashboards.
I'm quite excited about it because I know nothing about dashboards apart from they look pretty.
They're super cool. Yeah. I was talking with somebody earlier about some of the Elk stack with Elastic and Kibana, which is also super, super cool. So lots of fun ways to figure out what's going on. Yeah.
Years ago, I went. I had a tour around the offices of Agoda.
Sorry, quick question. Link to the current page. Somebody's asking for the link to the current page. If you can share that.
Let me remove the locale just so you get the one in your local locale. I will drop it in the chat. Well, I will drop it in our chat, and someone will drop it in the right chat. So, coming your way, Deepak. But yeah, so I was in Agoda in Thailand. So Agoda, one of the big travel booking places, just chatting to folks there. And literally, if we look, is a big 65-inch TV with dashboards, and they're just absolutely everywhere, all around the entire place. Not just for engineering, but even for the sales folks, the support folks, the whole lot. Everyone have all these dashboards, and they're trying to encourage this culture of just seeing the data, understanding it, and just looking at it and learning how to interpret it. And they got very excited about some of the dashboards they were showing. So it's kind of pretty cool to see. It's kind of just, it's always there. It's always around you. You always absorb all the data so you can see what you're doing, what impact it has. When there's an outage, everybody knows. Things like that.
I think that's the useful part of, at least for me, that was the biggest thing of the dashboards, is you could actually see it's so easy when you're just writing code and checking in pull requests and then ticking off features that like you're doing things, but it's hard to actually see what that is actually causing or any impact that's actually having. Whereas the dashboards make that very obvious. I think that's the useful thing. If you're looking for like understanding what's actually happening in a product, dashboards are really useful. I would highly recommend even getting like an e-ink display or something that is relatively low power but can display things. Like you can run a e-ink display off of a Pi Zero and for like almost no power. And that will be able to show you like some basic telemetry information about your app or your home. If you're just looking, like if we're talking about like home stuff, you can just measure your temperature and how much tea you have. Like you can just start small and then build it up to like monitoring your entire, I don't know, supply chain, or monitoring your entire like giant set of services or whatever you're actually building. You can expand from there. But yeah,
I've avoided going down the full home automation route to avoid having that situation, because I know that if I do set up a full home automation server and managing my things, I'm going to end up with a dashboard like that. And it's just going to be showing me what lights are on, the temperature, energy usage, I've got solar panels, so all that generation. I'm going to have that on a big dashboard, and the rest of my family are going to be probably not happy about the fact I'm covering the place in dashboards all the time.
Nice.
Nice.
Cool. We have like 50 minutes left. Should we finish up this design so we can actually like get at least some of the code? Because our main goal, I think, with this is to get things all the way up to IoT Hub from our sensors.
So should we kind of stop here at the architecture? We know we need to get to IoT Hub.
Yeah, so this is actually a really fun discussion for like architectural decisions and contracts and things like that. But like these endpoints are contracts, right? And so so I like to think of them as that. And so the cool thing is how you design these contracts can be really important, because those are the only things that really matter. Because everything else can change as long as the contract of what you're saying back and forth doesn't. It should just work. It's one of the cool things with like Open API, where you can just say, here's how this thing is going to communicate. And as long as you support that, it's fine. Implement it in whatever language you want, it's just going to work. And so here, I think if IoT Hub and those events become our contract, then I think we can work from that and just kind of build out the rest and do that. Does that make sense?
Yeah, because that's kind of the cool thing about all the services inside one cloud provider is they all talk the same language, as it were. So we've got on the IoT Hub here, there'll be what's called an Event Hub compatible endpoint, and that speaks Event Hub. So we can connect any Event Hub to it, or anything that talks to Event Hub can connect to it. So that contract is, as long as your service can connect to Azure Event Hub, you can pull data off here. But then if we need something that can't connect to Azure Event Hub, we can add something on that does connect to Event Hub that translates it into whatever connection. Sorry, Deepak's saying, don't see the link to the page. So I've put the link in our private chat, which at some point will be posted to the main chat. Sorry, because we're streaming on YouTube and Twitch at the same time, we use a tool in the middle to do all the streaming. So I can't drop it onto the YouTube chat. So I've put it in our private chat, and Firaz will drop it onto the main chat some point soon. There we go. There's the link for you, Deepak. So apologies about that. So as long as we establish the kind of messages that are coming off here, we can build anything we like that speaks event hub, service bus, kind of whatever those technologies on the other side. So yeah, as a contract. So really, as part of our contract, we need to think about what we want the message to be, so we know what we're pulling off.
So is this something that you define, or does IoT Hub define part of this for you?
So IoT Hub defines part of it. So when you send a message through IoT Hub will enrich the message with things like the device ID that it came from and timestamp information, things like that. So it builds up a packet of data. So you can get like a JSON blob of data coming out onto the Event Hub compatible endpoint. So you can click anything to it and just pull off this stream of data. And then all you have to do is, you have to just build the bit that you care about.
Okay.
If that makes sense. So the message that comes via IoT Hub will have a device ID. You know what? Let's change this to an appropriate font because it can. So you would get things like this already put on. Which I think it's _TS is the timestamp. So you get stuff like that already put on there by IoT Hub. So it kind of gives you all the bits. And then you'd have your, I can't remember off the top of my head what the actual things are, but then you'd have your kind of data on there as well. And this is the bit you would set yourself. So this is what comes from our IoT device. This would be, weight. And then we'd put, 60, whatever. So this bit here, this data, the contents of this data is what we would send to IoT Hub. And then everything else is IoT Hub enriching it with all the various information that comes from it.
Okay, so the other thing that I would think that we'd want is units. So we'd want some different units. The library we're going to be using has support for different ones.
Mm-hmm.
So we should probably call out what it is. The other option is we could adopt like some sort of canonical unit that we just always use, maybe grams or something like that, and do the conversion client side before we send it. Because I know we were talking that like data size might be our consideration, because I think IoT Hub is priced based off of events you send, correct?
Yes.
So we want to optimize for sending as few events as possible while still getting the most accurate data as we can.
Mm-hmm. Yeah. So that's I guess a whole other conversation around how often we send data. But yeah, in terms of the units, I'm always a big fan of defining up front what all your units are going to be, and then everything internally uses those units, and then it's client-side conversion. So that way we can do everything in grams. Yeah, that's an SI unit, a standard unit. We can do everything in grams. That way it becomes a fully global system. And then for the majority of the world, we can just display it in grams. For US, where they're like pounds and ounces, we can do things in pounds and ounces. So you can actually customize that. In fact, a lot of it is operating system customization. So in your OS, you choose whether you want things in American units or British units or New Zealand units or Chinese units, kind of whatever. So you could even pick that up from the locale of the phone that you're using to monitor it, or what have you. So automatically adjust it for you. So we do everything in grams, and then it's just the last mile we convert to ounces if somebody wants ounces, things like that. Same with dates. It's like, it's good to store dates in UTC and local time, so that you've got kind of a canonical view on everything for UTC, and then you can convert to the time zones as necessary, and local time as well. But that's a whole other conversation that we won't go into, because that will take many, many hours to talk about how you should store dates. But yeah, I'm a big fan of storing it in grams.
Okay. I think the only consideration I have that would say not to use grams is maybe we're going to use a smaller unit, like milligrams or micrograms. I think is as small as the library we have goes. But the advantage is that we remove floats. I don't know if that's something we want to, if we care about. But if we go to a small enough unit, we can not worry about floating point numbers and just like send up a long of whatever we're representing, or an int. I don't imagine we'd exceed the size of an int as far as weight goes.
Probably more.
How big is It's like 3 billion grams, right? That's a lot.
That's quite heavy. Yeah, that's quite heavy. If
I
you've
don't
got
think we're gonna have that much tea.
you know, I worry about the foundations of your building and indeed the city that you're in. So Keith Nicholas says we should always use SI units. Yes, totally. And saying about New Zealand units, we use metrics like every other sane country. Yes, metric for the win. I may live in the US, but I'm British and I'll be Celsius and grams to the day I die. But my comment about kind of New Zealand units, what have you, is a lot of it comes down to how you display time zones and times and currencies and things like that. So it wasn't just referring to weights in different countries. It was more a case of there's a lot of setting that you have on your device depending on the country you're in for, you display money in dollars or things like that. So that's kind of what I meant by New Zealand units. But Chalice of Choice asked the question, what tool is on the screen in which Sam is writing? Well, actually, it's not Sam doing the writing, it's me doing the writing. But I'm using a tool called Sketch. So Sketch is a vector-based drawing tool. It's Mac OS only because, I work for Microsoft, therefore I use a Mac. And no worries, Chalice of Choice, no worries at all. I was just being facetious. But no, it's called Sketch. It's a really, really good drawing tool. I use it for mock-ups. No, it's not for Ubuntu, it's just for Mac OS. But it's just a really good vector drawing tool. It's the one I've been using for years, so I just have it I use it for doodling on. I don't have, if I had a nice fancy Windows device with a touchscreen, I'll get a pen out and actually draw on something, but I don't. So yeah, sad. Yeah, I know. It's unfortunately because Macs historically for all the designers, then all the coolest tools for design are Mac only.
There are some cool extensions for like Visual Studio Code now that have started adding these kind of things. And the cool thing is they support like live share. So you can actually get multiple people together to actually start like tinkering together on different designs. I can't remember the one that I was looking at, but there's a few different ones. Yeah, Draw.io I think is the one that I was thinking about. There's a bunch of different ones that actually integrate with live share, so you can collaborate that way and actually do that. And it's right in your code too, so you can jump right over to code and do all that.
Okay, so you can use Draw.io to draw some SVG files. Nice.
Yeah.
Nice. That's cool. Or Figma. Yep. I mean, there's a load of tools. I've not tried the Draw.io integration, but I keep hearing good things about it.
I use Mermaid Js myself, which embeds directly into Markdown. So just you take a Markdown file and you just code that. That's not the same one.
This has got support for Mermaid JS.
Yeah. So Mermaid is a design language for doing cool graphic diagrams. Basically, what you're doing with the flow diagram, but you can do it by writing code. So you just write this node talks to this node, and that is named this, and then you just do that, and it generates the entire graph for you and gives you SVGs and things.
Nice.
So that can be a really fun way if you're more on the programming side and want something. And that also embeds into Markdown, so you can bring that to most like websites and things. So
that's cool.
Yeah,
that's
lots of fun options.
Eric Kelling says Mermaid is so nice. So that we have Mermaid fans. Cool. So should we actually do this? Let's talk about the hardware because we've only got 40 minutes left and we haven't even got the hardware yet. So we're going to send the weight, and we'll just agree to do it in grams. Because I guess one thing to think about is when you're sending data, how accurate do you care about? Because really, do we care about milligrams or micrograms? It's T. Whether you've got 231 grams or 231.5 grams, does it matter? So it's kind of something just you have to think about when you're capturing data is, do you want to just store it, take an int? Do you need to have the accuracy of a float? Do you need to have it in milligrams, or is that just going to be two big numbers? Ratio of T to T leads might care. Yeah, maybe. But, just for what we're doing, it's not, if you've got half a gram of tea, it's not going to make an extra cup, is it?
Right. And I think we're aiming for detecting like broader trends, right? We're not, because there is going to be noise, like this is going to be sitting on a shelf somewhere, and so it might get bumped or something else. I'm not or even just like dirty or whatever. It's going to be in a kitchen probably. So like things are going to happen. And so going maybe super specific instead of just looking for a reduction from some initial weight and volume down to 0, I think is sort of what we care about. Does that make sense? Because we know, theoretically, we know the volume. We'll know that when we configure it initially, and then as we finish tracking it, that should all come through, hopefully. So I think this makes sense.
But also as well, we should actually look at the output of the sensor, because sensors have noise.
Right. I was going to bring that up.
So
I don't know how precise these are. Mine seems like they have some noise to them, but they also seem like they've been having weird other issues. The wires with these are really finicky. I had a lot of trouble stripping mine and getting everything off without just pulling the wires off entirely.
So Chalice for Choice says, can't we average for a span of time and remove the outliers? Oh, definitely. Yes. We need to just think about if you pick up the tea, take the bag to somewhere to make the tea, it's going to drop from X weight down to 0. So you're going to get an outlier for that anyway. So we have to think about the outliers because they are acceptable changes. We're going to have a 0 when we take the bag of tea off to make tea. So we have to adjust for outliers. We have to ignore those and then average out over a period of time. But it's whether we do that device or cloud side, really.
I think that's actually one of the interesting things. Like, so I have a solution at my house for my refrigerator because one of the doors doesn't always shut. So I track it. If it's ever left open for more than 5 minutes, I get a text alert that says, hey, you left the refrigerator open. You should go close that. That could be something that we might actually want. If our scale suddenly jumps from like wherever it is down to 0, we probably want to know. We probably want some sort of message to come through or alert to pop up if there's like some huge anomaly that occurs. That might be something that we actually care about. So we can actually detect those anomalies, or like you have a cat and it knocks it over, like things like that.
Because a 0 anomaly you kind of expect for a short period of time when you take the tea off to make tea, but not for too long. Whereas a high anomaly, if the cat decides to sit on it, that is an anomaly you want to get notified about. And Chalice for Choice says an ML algorithm which can learn over time. So you do get anomaly detection algorithms. So anomaly detection is designed to take a time series and pinpoint anomalies. And of course, they can learn over time from your data. So if you have a regular goes to 0 because you're making tea, but no more than like a minute when it's off, it'll ignore those. But if it's off for 5 minutes, it'll alert you. Or if it goes heavy because the cat's sitting on it, it will alert you. So yes, anomaly detection. It's kind of a standard machine learning algorithm. We can actually run it. We can do anomaly detection at some point if you want. There's a thing called Stream Analytics, which can take data from IT Hub and then run anomaly detection over it. And it's literally it's one line of code to run anomaly detection over your data. So that's cool, but that's for another day. Today, let's look at some hardware. Let's look at some hardware because we've got about 35 minutes or whatever. It's 40 minutes to show off some hardware. So Sam and I both bought the same thing, didn't we? We bought this. So these are load cells. In fact, Sam, do you want to? Do you have one you had one that's detached, didn't you? So
I do. I can just hold it up here. But they look like this. Actually, the light kind of helps there. But they're just these steel pressed plates with some white goop in the middle, and then a little foot on the bottom there. So that's what's facing the camera. And they have 3 wires that are used to kind of make the circuit. And then what they do, the reason they're shaped so funkily like that is because they detect load by bending, by the bending and deformation of the metal. And so the reason there's all that stuff in the middle is to protect the sensor, which is super sensitive, that you don't want to mess with too much. And so basically, as that moves, it's going to detect different things. So Does that?
Keith Nicholas says, this is my jam. I did high-speed weight measurement for large industrial fruit sorting machines and now do remote monitoring systems, including weight for ag tech solutions. Nice. That's my jam as well. I love ag tech. So seeing some of the cool stuff they do for fruit sorting is brilliant. So, oh, yes, that's very cool. Hey, Keith, if you ever want to talk about this, if you ever want to come on one of these streams and actually talk about how you do this kind of stuff, I'd love to host you because I love that kind of stuff. So yeah, so the wires. Do you want to talk about the wires?
Sure. Yours look a lot neater than mine. So I'm really glad yours are up there. I like I was mentioning before the show, I have 4 different ways that I connected mine. Don't really recommend that. And also the wires are so thin. They're like 4 or 5 really thinly tied wires. And so actually getting them to like I was trying to use some of these which are like latch clips, I think that's what they're called. I can double check. But they didn't even really hold it. They just pulled the wire off. So had to go to other solutions, mostly involving tape and some solder. So
I went down the tape route. I mean, these wires are so thin. I could strip them with a fingernail. Very gently with a fingernail, you could strip the wires. I didn't even need work. My wire strippers were just too much for it. So I was just stripping with a fingernail, twist them together, and then just tape it and hope for the best. Because when you strip the wire, the actual wire inside is really, really tiny.
So I've been thinking about this actually after doing it. I think the best way to do this might actually be with some like copper tape, because most of those wires don't actually go anywhere except to the other wires. And so I think you could just run some copper tape around the outside, like all 4 sides of the back there. And I think that would simplify everything, because then you could just solder the wires directly on there onto the tape, and I think it would just work. I'm gonna try that between now and the next episode, but that's my current thoughts. Is I think that might be the best option if you're looking for a way to build this yourself.
Because here's the diagram of how to wire it up. So we've got the sensors here. There's upper left, upper right, lower left, and lower right. Hence why I've got U's, L's, and R's on here on my actual thingy. So upper, lower, left, and right. And so you connect. So the white and black actually connect them together in series. So it goes upper left to upper right on the white, lower left to lower right on the white, and the black is upper left to lower left and upper right. So it kind of connects up a grid. And then you have one control wire coming off each that then goes into this little device here, which is an HX711 weight module, whatever one name is. So this actually takes the inputs from those from the load cells, converts it into data that can be read off by an Arduino or Raspberry Pi or something like that.
Right, and so the white wires are just horizontal, right? So we were talking about each of the modules ends up in one of the corners, and so the white wires are connecting between the 2 horizontals, so the top 2 nodes and the bottom 2, and the black ones are the vertical ones, so left and right sides. And that's just how you have to wire them up. That's why I was saying some tape would be useful, because then you can just wire it up. Should be a little bit easier than working with those wires. So.
Now, just think about mounting this, because I've got mine on this block of foam, which I found. When you mount them, they need to flex. This is an important thing to think about. They need to be able to flex. So when you attach it, you've got to make sure there's room for it to move. You can't just put the whatever base you're looking straight onto the sensors. So I've got mine. I've actually got the outer rim raised up on some thick double-sided tape. I'm not sure how well you can kind of see that, but see it's away from the surface there. So that way the bit inside can actually flex when it's under load. If you don't do that, it can't move. We won't actually get any measurements. And then, yeah, so once the wires are done, connects to one of these. This is the load cell. The actual, the HX711, whatever it's called, that you connect it to. And then from there, I've got it wired to my trusty Raspberry Pi. All right. This top tip, this doesn't come soldered. So if you can't solder, then you need to get someone to solder that for you. I'm not very good at soldering, but I'm quite impressed. I didn't actually ruin this one. It actually looks quite reasonable, which I'm quite pleased about. It's like terrible at soldering, absolutely terrible at soldering. So yeah, and then it runs on 5 volts. So the Raspberry Pi, it's got power. You can tell it's power because I'm using yellow and blue because I couldn't find my red and black wires. But yeah, so it takes 5 volt power and ground, and then it's got a data line, a clock line comes out into the Pi itself. And that's the hardware. Yeah, it's just the one problem you've got is where it's these thin wires. So you've got these thin wires on it. When you connect those to here you need the jumper leads. They're called DuPont cables, I think I've seen them referred to as. And so obviously you've got there's pins on here, but then you've got these really thin wires. So I just went through a terminal block and then just took some of these jumper wires and just cut the ends off so I could put those on a terminal block and just slide those onto here. But yeah, otherwise you've got teeny tiny, really thin little wires. You're trying to get in the hole and solder them in place. It's not exactly a fun experience. So
the wires did come pre-stripped. I bought 2 different versions of this from 2 different places, and then the wires are pre-stripped, but they're really thin.
Mm-hmm.
So if you have anything that's like a friction hold, any like pulling or anything is going to just yank them right out. So yeah, maybe it'd be a good use case for like some hot glue too. That might be helpful.
Yeah. Especially if you're using tape as well, using tapes. When you connect the wire to tape, you want to put some glue on top of it to stop it be able to come out. Yeah. And then obviously you need something. So these cells need to sit on something, and it needs to be something reasonably sturdy. Yeah, you can't just put on a bit of cardboard because the cardboard will actually buckle rather than carry the weight. So it needs to be something that can take the weight. Me, I just used a block of foam because I had some to hand, and I'm not that fancy. Sam, on the other hand, got very fancy, didn't you?
I did. So I made this. So this is mine. It's the same exact thing. The front part is just for show, and then it's just MDF on the back with the sensors on there. And then I have a bunch of my notes on there to wear it all up. And they're just all glued in to the thing. And these can all just be screwed off so I can play with it at different points. But yeah, it's just another option for doing it. It's basically what we're building is a bathroom scale, right? I that's basically what this is. It's just a bathroom scale that has different weight parameters, and you can hook up to a Raspberry Pi, so you can do this. This one probably wouldn't work as an actual bathroom scale. It only goes up to 50 kilograms, but you could probably find load cells that would do that if that was a project you wanted to do. So,
yeah, there are ways to go. You can get ones that go higher. I think there's you could do some kind of configuration for it. I saw where you could actually do, you could get it up to 200 kilos somehow. So I think each cell is 50 kilos. So yeah, if you form a full bridge, you can get 200 kilos.
Okay, that could be interesting.
Yeah, so it involves a bit of wiring and all that, but yeah, you could in theory go up to 200 kilos. So. But yeah, so that's the hardware. As I said, it uses this HX711 weight module. Now, I'm a huge fan of Charles of choice saying 200 kilos. Is that a question as to what 200 kilos is, or is that a question on just surprised at that weight?
200 kilograms is like 450 pounds.
For such a tiny sensor. Yeah, that's what it says. That's what it says, 200 kilograms. Surprised. Yeah. Such a tiny sensor. So if you think about bathroom scales, a lot of them you kind of see it's kind of a glass plate, 4 corners. And that's basically these inside those 4 corners. So yeah. I'll have to try it. I'll have to stand on it later, see what happens. Probably break. Maybe after the series is over, I will stand on it and yeah, see if it breaks. So yeah. Now, so this is a HX711, I said. And one thing I love about Raspberry Pi, so I love Raspberry Pis, and anyone who's ever seen any of my IoT talks, I can talk way too long about Raspberry Pis. But one thing I love about Raspberry Pis is you can probably find a Python library for everything you want. So I'm a fan of Python because I find it pretty easy just to get going with these kind of small IoT projects. But you can usually find a Python library for the kind of stuff you want to do, and that, for the Raspberry Pi. It's a huge ecosystem of stuff for the Raspberry Pi, which is fantastic. So I just Googled with Bing the HX711 Raspberry Pi, and I hit this particular repo here, HX711-RPI-Pi, and it's got everything you need. So it's a wrapper for a C++ library. So sometimes there's a lot of low-level C++ libraries that read data. This is a wrapper for it, and you can call it in Python. And just it's not very many lines of code to actually use it. So totally on board with using this. This was like, yep, this is what I'm going to do. I had to build the C++ library. The C++ library that came with it has to be built. And that relies on LGPIO, so GPIO library. So it's it was very much, I need this library here, but from the C++ library, it had run this to install the dependencies, and that was still the LGPIO library, and then you just clone it, make it, that installs the C++ library, and then from there, you just pip install the Python package. Now, Sam, you're a .NET fan, aren't you?
I am, yeah. I have historically gone the .NET route. I went Python this route, but it does look like there is some .NET support for this. So that might be something that if people are interested in, we could dive into. Maybe go on a little bit of a detour into .NET land.
Yeah, there was one. Of course, .NET, sometimes it comes up with other things. That's Arduino libraries. There was one. I did come across one.
Yeah, we've been throwing links back and forth, and it might have gotten lost. But I think there is one. Neither of us have explored it, so we don't actually know. But we have done .NET on Raspberry Pis before, and there's a lot of different things supported, so we can experiment.
Now, one thing about these load cells do not give you weights. So if you just put some in the load cell, it won't tell you how much it is. It gives you just a number, and you have to calibrate. This is one of the fun things we have to do. We have to calibrate. So we need to make sure that we put a known weight on here, and we use that to get a number that we can calibrate. But this library comes with the script. So I've calibrated mine, but it comes with this whole calibrate script, which is pretty useful. And you run this, and it then calibrates your device. So if let me connect to my Pi. That's the cool thing. If I connect to my Pi, I can then run the calibrate script, and we can just do some calibration. What do you reckon? Sound fun?
Sure, let's do it.
So
that actually might be what's wrong with mine, because I had to redo a bunch of things after doing that. So
yeah, probably needs recalibrating.
Maybe.
Now I'm going to highlight this. If you haven't come across this before, this I love it. So there's for Visual Studio Code, there's a remote developer extension. Allows you to remotely connect to devices and then develop on those devices. So what I can do is I can connect this to my Raspberry Pi, give it a few seconds, and I'll be running VS Code on my Raspberry Pi. It's running natively on my Mac, but it'll be connected to my Pi, and then I can just browse the file system of the Pi. I can open up files in the Pi. If I debug, it runs the debugging session on the Pi. It's like I'm developing on my Pi, which is pretty cool. So give this a second, and there you go. I'm on my Pi, and I've already downloaded the calibration script. So if I just run this, calibrate.py. I need to give it my 5.6. There we go. I forgot what pins I used. So if I zoom in a bit more. If I run this, calibrate, and I give it 5 and 6, these are the 2 pins, the pin numbers that the cables are plugged into. I run this, and then so I've got if I just sit back to my camera, there's my device there. It's currently got nothing sitting on it. I can choose the unit I want. I want grams. And then I'm going to weigh, I need to put a known weight on it. Now, I could have bought like a kilo of something, but I'm going down the old-fashioned route. I've got some kitchen scales here, and a block of post-it notes. So what I'm going to do, I'm going to weigh my post-it notes on my kitchen scales, because that gives me a known weight. Yeah, there's no point in, if I could grab a kilo bag of sugar, it might not be exactly a kilo. So if I weigh that, that's 259 grams. So that's the weight it's going to be expected when I put a weight on it. Then choose a number of samples. So it keeps on reading from the device. You're going to get fluctuations and all that. So let's go for 15 samples. So first we run it off. So with nothing on there to give kind of the 0 rating. So I run this. So that's not giving me my 0. So I then take my block of post-it notes, which I know is 59 grams. I'm going to place it gently on the scale. So there's my post-it notes on there. And then press enter. And there we go. And this is given a reference unit and a 0 value. I have no idea what those numbers mean, but what it gives me, this thing here, is it gives me this that I can put out there. And this is my line of Python code. This is what I need in my code. So if I've got a local folder here with some stuff in it. I just open my folder. Put that in there. That's what I just read. It's the reference data. So this is the Python code I've got. Brings in the library, creates one of these, sets the unit to grams, 0 as a scale, and then just polls. Just takes 35 readings each time and shows the weight. So if I just take my thing off here, start with it on 0, and I run this.
So one thing we might want to call out is that there's 2 GPIO ports you're using, and they're not the same. One of them is the clock timer. I think it's the second one. The 6 is measuring the clock. That's controlling like when to pull. The other one is actually controlling the data. And so you do actually need to check those. It's marked on these chips. DT is the clock. So if you're looking at that and trying to figure out which one is which.
So DT is data, SCK is the clock.
Oh, that might be why mine doesn't work.
Kind of, yeah. DT for data, and then SCK for the SPI clock.
Okay, so backstory. I'm coming from game development where we do delta time.
Yeah, DT is data.
Data. That makes way more sense. Okay, cool. I'm learning things.
So you see the scale's kind of settling a bit. It's going up and going, kind of slowly going up because it's kind of just settling a bit. But if I just put my weight on it, that should. So it's not 100% accurate. It's not totally accurate. But this weight is like 280 something. That's how much this weighs. It should be 259. So it's not, my calibration's maybe not quite right. Maybe I need to change how many readings I take or what have you. But that's kind of, you see what fluctuation. It's gone from 278.2 up to 282.6, 283. And then if I take it off, that will drop down again. Now there could be fluctuations because I've made errors in maybe it's not resting properly on the bed. Maybe using foam wasn't a good idea. But at least it gives us numbers. And as long as we know what the 0 number is, we can just measure the trend towards that. So yeah, if you swap your cables around and try calibrating yours again, I wonder if it'll actually work now.
It probably would work significantly better than it currently does, because it was just giving me like random things. So now I can actually speak a little bit about how this breaks if you do that wrong. It freezes Python. If you swap the 2 pins, it locks up the code. You won't get any results.
Because it's trying to read from the wrong wire and it's actually waiting for the data to come through, and of course there's no data coming through.
Right, and because it's waiting, it wasn't even getting like the control C signal. What is that? It's not signal kill. It's like signal terminate. Something. It wasn't getting that one. And so you have to go a little bit out of your way to make it not there anymore.
Yeah. So challenge of choice asked the question: why did the initial stage increase to 12 or so? Should it correct to 0? And the reason for that is obviously the metal flexes over time, and then the thing that it's on kind of can adjust. I've got mine on basically a foam block. So it's so sensitive to movement that a lot of it's going to be down to just my foam block deforming very slightly as weights go on it. I probably should have put something a bit more solid on there. You know, you don't get bathroom scales made out of foam. They're usually like glass or something that doesn't actually bend. So it's probably just related to that bending, or they've got that double-sided tape around it to hold it in place. That's going to have a certain amount of flex in that. So as that adjusts, that will then just adjust the measurement of weight, because it's such a tiny thing in there. You need such very tiny stresses on the metal to get readings. So you'll see it's dropped down to 11 and kind of coming back up. It's kind of just slowly settling down.
Well, and also our scales can measure up to 50 kilograms, and we're currently measuring like a small fraction of that range. So if you want something that is that has more precision, you might want something that has less range than this. These were options that I think were like a good budget choice, because they were in the range that we needed them to be, and also they're cheaper than a lot of other options that we were finding. So yeah, you can pick these up for $9-10.
Yeah, $8.99 with free delivery on Amazon Prime. So, you know, they're not the top of the range sensors, but they do for this. So yeah, eventually you see it's kind of leveled out about 20-ish. So that will, yeah, obviously if we're looking over time, yeah, we're only doing this in space for a few minutes. Over time, it will level out. But yeah, if I'd had, can we tear it out? So that's what the calibration does. So that's why when you calibrate at 0, then you calibrate with the weight on. So it does have a 0. So you can actually do a 0 here. So you could put a weight on it first, then call 0. So you could, if you want to tear it out, then they're calling 0. HX.0, that will do that for you. So if you wanted to do that, if you wanted to have like a base weight, if you wanted to weigh, just the tea, not the container for the tea, then we could put the container on and tear it out, or we use the container when we calibrate. We've kind of got different options to how we can do that. But yeah, see, it's kind of settled 18, 19, 20. That's kind of where it sits. But this goes back to the question about, should we send floats? Well, this scale is not that accurate. So it doesn't matter whether we send 18 or 19, because it might be, 18.9, 18.4, 19.5, doesn't matter. We might as well send 18 or 19. So we know we can, based off this data, we can get an idea as to how accurate the data is that we need to send up. So this is kind of good for that kind of spike. Yeah, we can kind of experiment with this, can't we?
Well, and this library already averages things behind the scenes as well. I think the default is a median. I think that's what the comments say there. But we're actually taking the weight over 35 readings. So there's 35 readings from the sensor to produce each one of those readings. And that helps get rid of some of the noise. So we could increase that even higher and get rid of even more of that, or bring it all the way down to like a 1. And then you'll get a whole bunch of readings, but they won't really mean all that much.
Yeah. So if I do 1,000, it'd be a lot slower. I mean, I don't necessarily care about, but that will then give us. That's a lot slower. That is a lot slower. But that should give us better readings because it's averaging out over time.
Yeah, I think it's like a 60 hertz chip. So 1,000 is going to be like 20.
Yeah.
Something, some amount of time. There's my very unspecific thing. So how do we get this up to IoT Hub? Can we do that in 10 minutes?
Yeah, we can do that in 10 minutes. So
awesome.
first thing we need to do is we need an IoT Hub. So I'm going to do it from the Azure portal. I'm a big fan of Azure portal because I don't like remembering CLI commands. So when you create services in the cloud, you can do it from the website. You can do it from scripts. You can do it from the CLI. You can create all manner of, you can do it in code using tools like Pulumi. Loads of ways to do it. I like the UI because I can't be bothered to remember all the different options. So I can go in here, search for IoT Hub, and create an IoT Hub. So I just click create, up it comes, pick my subscription. There we go. Create a new resource group. So Azure groups things in resource groups. So You have a resource group, just a logical grouping. It doesn't mean they live on the same computer, data center, whatever. It's just a logical grouping that you can then manage as a whole. So when we're done with this, I can delete this resource group and it deletes everything inside it. It's kind of a little useful thing if you've not come across those before. We should call this IoT. Oh, IoT hub name is not available. There is an IoT meetup in the UK run by some very awesome folks. And so they probably nicked IoT for that. We want WestJS 2. So I call it IoT reactor stream. The name has to be unique because this comes as part of a URL. So when you actually do a connection string to connect, it's got this URL in it. So it has to be globally unique. And then the region is just where in the world we want to create it. I'm going for WestJS 2. It's the nearest data center. Networking, we set up public and private networking. We won't worry about that. Management. This is something that we'll talk about a little bit now, but we can talk about this a lot more next time, is the scale. Now, there's different tiers of IoT Hub and then different numbers of units you can apply to it. So this is the standard tier. If I have 1 unit of standard tier, I'm allowed 400,000 messages a day. And that costs me $25 a month. Now, how many messages a day are we going to be doing? This kind of opens up a whole big question of stuff, which maybe we'll save that for next session. Free tier. This is the cool one. The free tier. You can allow 1 free tier unit, 8,000 messages a day for the princely sum of a big fat 0. So I doubt we're going to need more than 8,000, really, just for team monitoring. So we can create a free tier one. And you allow 1 free tier per subscription. So I can have 1 free tier and that's it. But it means I'm not paying anything. So I'll create a free tier for now. The free tier is fully featured. Does everything the standard tier does. It's just free because you've got message limit. But what's nice is the message limit is like a hard block. When you hit 8K, it just stops processing any more messages. As opposed to when you hit 8K, you start paying. It's when you hit 8K, it's blocked. So you never, ever pay, which is really nice. Because you get some tiers where it's like, oh, it's free up to a certain amount. And then after that, you kind of pay. And if you end up going over, IoT is very easy to wire up sending a message with no kind of sleep. So you start sending hundreds of messages every second. And you don't end up suddenly paying for that because that'd be a very bad thing.
Right. Okay, that makes sense. You don't want to flood it with messages overnight and then wake up and be like, oh no.
Wake up to a nice big bill. You don't want that. So that's the thing. It's all a hard limit on all these things, which is nice. You can set up alerts. So if you're paying for, the S1 or S2 or S3, if you're paying for lots of messages, you can get alerts when you get near the threshold. So do you need to scale up? But for what we're doing, 8,000 a day, fine. Click create, and this is going to go off, and it's going to start spinning it up. So while that's spinning it up, let me show you the SDK. We have a whole lot of SDKs for this. .NET SDKs, we have that. Java SDKs, JavaScript, whatever. We have all the SDKs, and we have a Python SDK. And that's got all the stuff you need to access it from Python. And it's on there's a pip install. So if I go look it up on, there you go, pip install Azure IoT Hub, or there's Azure IoT Device. So there's different SDKs. This is just the hub one. So there's different SDKs for there you go, device library. That's what I wanted. There's one for device or one for the hub. So there's an SDK for you're a device, you want to connect and send data, or a different SDK for I'm a service that I want to talk to the devices. So I can go here, pip install, over here. Oh, there we go. Much less fluctuation, but takes a very long time. We'll put it down right now, 35. Come on. Just kill that terminal, start again. I can just pip install this. Weird pasting going on. That gives me the IoT device. I'm sure people who are Python developers are horrified at me not using a virtual environment to isolate my packages. I don't use virtual environments that much on Raspberry Pis because I just wipe my SD card and start again. So virtual environments are ways of keeping your packages unique. So in this virtual environment, I've got these packages. and then I'll run my code in this virtual environment. And when I install the packages, they just go into the virtual environment, not everywhere else. It's kind of like having NuGet packages in your project file. It's kind of just a way of kind of keeping everything contained. But on a Raspberry Pi, my virtual environment is my SD card. So yeah, I don't care. I'll just install it straight, and that way I can access it from everywhere. Yeah, version conflict avoidance. Yeah, virtual environment means I can have a Python 3.9 virtual environment with version 1 of a package, and then I can have a Python 3.10 virtual environment with version 2 of the package, and kind of flip between the two.
So virtual environments are different. They're not containers, but they sound very similar. Is that accurate?
It's a container just for your Python libraries. Yeah, you can kind of think of it like that.
Okay.
So you activate it and it's running. It's got its own copy of Python, and its own, all the packages that you install is running from there. And then you can delete the folder the virtual environment lives in, and it just goes away. So that's it. I don't do those on Pis because I just wipe my SD cards and start again. So that's doing that. Yeah, there's plenty of sample code available for this Azure IoT device. I've only got a few minutes, so I'm just gonna grab some simple sample code. Let's get a nice let's not even do async. Let's go for a synchronous sample, a simple send message sample. So the GitHub repo for the SDK has got all the samples in there that you need. So I'm just gonna copy and paste a few things. Bosh, come over here. And then
and then the message you're sending is just a string. It's not anything special at all. It's just a string, right? So you can do anything.
Yeah, you can literally send anything. So first we bring in the package, Azure IoT device. That's the pip package. We then define a connection string, and the connection string is for each device. So I'm going a bit quick, but only got a few minutes left. My IoT hub has been created. If I go to my IoT hub, I can't just connect anything to this. There's security in IoT hub, so you have to define the devices either up front or use a thing called the device provisioning service. So your device has to have a special key to say that it can connect, either because the device has been predefined, or there's a service you can go to say, define me as a device. So it's all kind of secure. You can't just have anything sending data. So I go in here, add a device. I'll call this one Jim Scales. Create this device. Done. Device is created. And then I've got these connection strings. I'm going to show these. This is very bad practice on a stream, but I'm going to be blowing these away and recycling these keys as soon as the stream is over. But this is my connection string here. So I copied my connection string from my device, and this has got IoT reactor stream.azuredevices.net. So it's got the name of our IoT hub in there. So we know it knows which hub to connect to, device ID of Jim Scales, and then the shared access key. So this is my secret key. Without this key, I cannot connect as Jim Scales. And this key is unique to this device ID. So if I had a different device ID, I'll need a different shared access key for that. So I copy that, zip open code. Got that in there. And then I can create a device client from that connection string. And then connect. And that will connect my device to the IoT hub. And then what I can do is I can go in here and I can pull out the weight. The weight equals that. And then I can send a message. So I can send a raw string if I want to, or I can actually send a JSON blob. There's a message object you can define to do things, stuff like that. Just a basic JSON one, we could go message JSON, create a JSON blob, weight, and that can be the weight. If you want, we can even cast that to an int just to get rid of any issues. And then we can bring in, there's a JSON package, and then zip, zip, zip. I know I'm different for the code, but yeah, just for the sake of time, I go JSON dot dump to a string, and then message JSON. And there we go. That will then send the message up to IoT Hub. So in theory now, if I go python app.py, You won't see anything because oh, been bad Python. It's a mass object, isn't it? It's a mass object.
Right. I don't think it's a float. Unfortunately, you get something back. Let me quickly check here. There's some docs on this.
Okay, so we can get the version of that. I mean, you know what I'm gonna do? I'm just gonna add a print in here so we can see what it is. This is kind of boilerplate code. It's create the device, create the collection string. Oh, and a mass is not JSON serializable. So
it looks like if you just wrap it in a float, it should just work.
A float.
Yeah.
Okay. Let's try it.
We are making T scales. That IoT connected T scales. This is sort of the first episode, but we are making some scales that can track T usage over time using some fun IoT stuff and some Azure stuff. So if you're really curious and want to catch back up and you've just joined now, these episodes typically end up on the Reactor YouTube channel within a few days. And so that would be a good place to go and check them out. We'll also be streaming Mondays for the rest of this month and into March to kind of finish this project up. So the next stream is on Monday. Next Monday at, I believe, 10 a.m. I can double check that too.
Yeah, we're alternating between kind of morning and afternoon Pacific time for a few weeks just to make it more open to people at different times. So now I've got this JSON coming through here. So this is my JSON that's being sent. I've just used the float, as Sam looked up, to convert the weight to the float. And then from we're just convert it to an int because I don't need that level of accuracy. Chaz, a choice is at 2 p.m. for the next stream. That would be, I'm not sure where in the world you are.
Says, so 10 a.m. Pacific time. I have the meetup here. Actually, here, we can just, I'll post this in the chat and then we can pass this along to you. But we have a whole set of sessions. We've been moving a lot of the reactors content over to our GitHub. So a lot of our new sessions are now being posted there, so you can find what times things are happening there and figure out which ones sound interesting and come and join them. So
cool. So we've got the weight coming through, but it's going to IT Hub. And as I said, IT Hub is just a pipe. Yeah, it's just a message broker. We can't really see what's there. So there's an add-in I can install to Visual Studio Code, which means I can actually view the data that goes into IT Hub. So it's an IoT one. I can install that. And done. That's all installed. I just need to sign in with the device code. I don't want to copy it. I don't want to copy it without opening it. So I'm going to sign in with the device code. I go to my Azure here. I forgot what the link is now. Sign in with device code, device login. Microsoft.com device login. So give me a second. Cool. So I should now be signed into Azure on here, which means I can go, I've got an Azure IT Hub just appeared here. And then I can choose my IT Hub. All done through a nice UI. That's my hub. There we go. This is my device. And I can say, start monitoring built-in event endpoint. And there you go. This is the actual content. So it's just giving me the body of the message, the weight to 59,260. But you notice it's got a time and message received from. So that's kind of embedded in the actual whole message that you get. It's all the extra stuff, but that's what we're seeing. So as we weigh stuff, so if I take this away, take this off there, the weight will drop down, and you should see that we're getting, there you go, -1 coming into IoT Hub. So we've got all the data going from the scales up to IoT Hub. And as Chaz's choice says, yeah, much better reading this time by giving it time for it to settle and then just converting it to an int kind of gives better readings. And that is our data going into Azure IoT Hub. All done very quickly because we spent far too long talking about tea, or not long enough. I think you'd agree, Sam, maybe not long enough talking about tea.
Yeah, I mean, inappropriate amount of time. Hopefully people can join us for the next episode. Sorry, my doorbell's gone off, but hopefully people can join us for the next episode in on next Monday, and kind of help explore all the fun new things we're going to be doing, expanding on this, and hopefully getting some data ingested and put into a database somewhere. So
yeah, that'd be very cool. And please, everyone, don't buy all the load cells because Albatross D can't get to their Amazon account till tonight to buy one. So don't buy all the load cells. But thanks, everyone. We do run surveys just so we can make sure that we're actually doing the stuff that you want. We do a lot of programming on the reactor. We just want to learn from you what you want to make sure that we can provide you the kind of content that you're interested in. So please, aka.ms/reactor/survey, and the event ID is 15297. Please go there, fill it in. We'd love to know what you liked, also what you didn't like. We'd hate to be doing this if you think, yeah, this is not interesting. We want to know what you don't like about it so we can make things better for you, or what you like about it so we can do more of it. So please, please, please fill in our survey. But yeah, otherwise, Sam and I will see you next time.
Well, and remember, if you're building this, let us know. Show us some of the cool things. It sounds like some of you are planning on exploring this as well. So let us know what you're building, and we love to see your creations and how you're using them. So
yeah, definitely. We will be putting all this code eventually into GitHub as we go along. So at some point we'll put a GitHub. I guess next week we can share a GitHub link. Chalice of Choices, post the link again, please, to the survey. Yep, done. It's in the survey. Survey links now in the chat there for you, Chalice of Choice. So yes, thank you very much. But yeah, we'll put this code in GitHub for people to experiment with once we get a bit more code than the 13 lines of code that we've got so far. But yeah, otherwise, thank you very much. And yeah, please, as Sam says, tell us all about your stuff because I get very excited about it and I want to get excited about more things.
Thanks, everyone.
Cool. Thanks, everyone.
Thank you, everyone. Thanks a lot, Jim and Sam. We appreciate it. And for everyone, please, as Jim said, don't forget the survey if you have time. And other than that, hopefully we'll see you on episode 2. Thank you so much.
Cool. Bye, everyone.